Hey everybody, it's Mr. N here, and this is a last-minute review for the 2018 AP Calc test. So let's get started. On this first one, we're asked to find the limit. Okay, so let's try first with direct substitution, as we know, and we will plug in the 0, and we put in a 0 there, put in a 0 there, and we end up with e to the 0, which is 1 minus 1, over the sign of 0, which is 0, so we get 0 over 0, and this is an indeterminate form. So this is, since it's indeterminate, what we could do is we could L-hop it, so we're going to use L'Hopital's rule. So we'll L-hop, and then we end up with the limit as x goes to 0, and then we're going to take the derivative of the top, and the derivative of the top ends up being e to the 4x times 4, and then we take the derivative of the bottom here, and the derivative of the bottom is going to be cosine of 2x times 2. Now we plug our values in. So we're going to go ahead and plug in 0, so we'll end up with e to the 0 again, which is 1, so on the top will be 4. Plug in 0 here, cosine of 0 is also 1 times 2 is 2. Reduce this down, we get 2, the answer is B. Alright, for the next one, for any positive integer, k, the limit as x approaches infinity of ln x over k to the x, and we need to solve this. Okay, well, let's go ahead and try the direct substitution approach again. When you put in infinity, you're going to get a really big number. When you put in infinity on the bottom, over a really big number. So again, this is an indeterminate form. So what we need to do is we will L-hop again. And on the top, when I take the derivative, we end up with the limit as x goes to infinity. And this is going to be 1 over x. On the bottom, we're going to say k, because times x to the k minus 1. Again, k is just going to be a constant here, any positive integer. So we can use our derivative rules. And now when we plug this in, or we can actually clean this up and just say 1 over x times k to the x, k minus 1. And when we plug it in, we're going to get 1 over a very big number, so 1 over infinite, which comes out to be 0. All right, for number 3, the cosine x over x squared plus 4x. Well, one thing that you got to understand here as we go to infinity is as I plug numbers in, this is going to oscillate. It's going to go, no matter what I plug in, as the numbers get higher, it's going to oscillate between plus or minus 1. And on the bottom, it's going to go to infinity. So even if it's getting towards negative 1 over infinity or positive 1 toward infinity, either way, these both approach 0. So this one, you just got to kind of think about it a little bit and then determine from there. So the answer will be 0. All right, number 4. We'll take a look at number 4. If you look at it very carefully, this is the derivative definition for f of x equals the cosine of x at 2 pi. So we're going to go ahead and take our derivative here, and this gives us negative sine x. And then we want negative sine of 2 pi, which comes out to be 0. All right, number 5. Over here, we take a look at it. We do our direct substitution approach, and we end up with 0 over 0, which is an indeterminate form. So let's go ahead and L-hop. We L-hop this, and then we're going to end up with the limit as x goes to 0, and this will be first times the derivative of the second. Here we're going to use the product rule, e to the x plus the second, e to the x times the derivative of the first, which is 2x, all over. On the bottom, we have to take this derivative, and then we are going to end up with just negative sine x. Okay, plug it in again, 0 over 0. Another indeterminate form. L-hop one more time. Let's see what happens. So this time the top is going to become first times the second again, x squared times e to the x, and this will be plus the e to the x times 2x. And then take the derivative again of that other part, so you'll get e to the x times 2 plus 2 x times e to the x. On the bottom, you're going to end up with negative cosine x. All right, as we plug in our 0 value, because this is the limit as x goes to 0, we will end up with, on the top, when you plug it in, you end up with negative, or you end up with positive 2. On the bottom, you're going to end up, when you plug it in, negative 1, so negative 2 is the answer. All right, let's take a look at the next problem. Let's slide this up, and it says, consider the following equation. Find dy dx. All right, let's go through the steps here. So we will go ahead and take this derivative, and we end up with 2 times x minus 1 to the first power. Now, I could put dx over dx, because I have to take the derivative of this, right? And we put dx over dx, but we're just going to not do that. I'm going to use the y prime notation instead for this one. Remember, y prime means dy dx. So I'm just going to go ahead with the y prime notation. And then here, 2 times y plus 1 to the first power. Now I need a y prime here. Or you can write it as dy dx, whatever makes you happy there. And then here I have to take the derivative of this, which is 0. Be careful, this is a common mistake. A lot of students forget to take the derivative of that, and we'll put 2 right there, and you end up with the wrong answer in the end. Okay, so now let's go ahead and solve this for y prime. So I'm going to subtract the 2 times x minus 1 over, and then divide. So I end up with y prime being, I'm going to subtract this one over, negative 2 times x minus 1 to the first power, and then I'll divide it by this 2 times y plus 1 to the first power. So we end up with, that reduces with that. Now you could leave it like this, or you could rewrite it as negative x plus 1 over the y plus 1. Either way. But there you go. That's that first derivative. Okay, now in part B, it asks us to write an equation for each horizontal tangent to the graph. All right, so let's take a look. Horizontal tangents is when we have our dy dx equal to 0. And now we have a dy dx. So that means I need the negative x plus 1 over y plus 1 to be 0. So, let's correct this. This should be, let's see if the eraser tool wants to work for me again. This should be up here, negative x plus 1, like that. Okay, so then at this point we will cross multiply, and then we end up with negative x plus 1 equals 0, so x equals 1. And now, since we have a tangent line, this yields y equals plus or minus root 2x minus 1. Now here's the thing. You could think of this as y minus y1 equals m, x minus x1. The slope is 0, right? So then you put in the, up here, the way I got this was I just put in the x, this value of x equals 1. I just put it in the, I will see if I can highlight it. I just put it in here and solve for the y. So you could go at it that way, or you could think of it like this, in this manner. Also, if you take a look at this, what you really have here is, if you look at this equation, this is the equation of a circle, and it is a circle that has a center at 1, negative 1, and a radius of root 2. So if you had set this up, let's put a little quick axis for you here. If you had set this up, you would have 1, negative 1 as the center, and then you would be going root 2 in each direction, right? And so we would sketch our circle in here. So these are the horizontal tangents, and they are going to be at this negative 1 value plus or minus root 2 away. So you could think of it that way as well. All right, moving on to part 3. So let's take a look at this, or part C here. The line y equals x plus b is normal to the graphs at point P. Find the value of b. All right, so what we can do is, this is a normal, and we have y equals mx plus b. Remember that. Well, what is our slope here? Our slope is 1, but this is a normal. So to get a tangent line, we want the perpendicular of the normal. So the tangent line would have a slope perpendicular to this normal, which would be -1. So that means dy dx is -1, and that gives us this negative x plus 1 over y plus 1 to be that value. So we can cross multiply here, and we can get negative x plus 1 equals negative y minus 1, and y would equal x minus 2. So that means our b value is -2. All right, let's slide this up a little bit here and look at that last one here. For this one, it says, write an equation of the tangent line to the graph at the point P. Okay, since we know that this is at point P, that this is a normal, and they told us our tangent line is going to be y equals mx plus b, of course, and here our tangent would be m equals -1, which we just solved for, because we knew that from the problem right above for this case. And doesn't matter where P is on the circle. Well, it does matter where P is on the circle, but we're just working with what we have. And here we end up with, we know the B is -2 from the previous problem, so we just end up with y equals -x minus 2. Okay, moving on to the next problem. Let's go ahead and enlarge this a little bit so we can take a look at what's going on here. Okay, it says consider that differential equation, sketch a slope field, and at the 6 points indicated. So here's the 1, 2, 3, 4, 5, 6 points. These are those 6 points that they have indicated right here. 1, 2, 3, 4, 5, 6. Okay, so we're going to sketch a slope field for this. So let's go ahead and take a look at what we have. Since we have this differential, let me show you up here, that differential, we're going to go ahead and plug x and y's into it. So when x is 1 and y is 0, we can go about it in that manner. So when x is 1, y is 0, I end up with 1 on the bottom and 2 on the top. So I end up with a slope of about 2. So I'm going to sketch this in and up 2 over 1, so like that. Okay, then I'm going to do it for all these other points. This one ends up being like this. At the point 1, 1, I get 0 on the top, and so that's going to do that. And in fact, any time y is 1, I'm going to get a 0, so these are all horizontal tangents. And then over here, the slope also ends up being 2, and then the slope ends up being like that as well. So that's just at those 6 points. All right, now we have y equals f of x be the particular solution to the differential equation with the initial condition. So we have an initial condition, right, an equation for the line tangent to the graph of f at the point 1, 2. All right, so what we need to find a slope. And this is our dy dx. And we're going to go ahead and plug in the value we're given. X is 1, y is 2. So this becomes 2 minus 1 squared over root 1, which gives me 2 times 1 over 1, and that gives me 2. So we have the point 1, 2. We have y minus y1 equals mx minus x1. So this becomes y minus 2 equals our slope, which is 2, and then over here, x minus 1. So that's our tangent line. Okay, find a particular solution to y equals f of x to the different with our initial condition now. So now they are asking us to find our solution with an initial condition. Okay, so we have dy dx being 2 times y minus 1 squared over root x. So we can go ahead and separate the variables. So this ends up being, let's just say dy over 2 y minus 1 squared equals dx over root x. Now you could have kept the 2 on the other side. It's okay. So let's go ahead and at this point we're going to integrate each side. Okay, and we will end up with on the left side. You could go ahead and do it with any, if you want to do it with a substitution, it doesn't matter, any method you want, but in the end you're going to end up with negative 1/2, or 1/2 times negative 1 times y minus 1 to the negative 1 power, and you could verify that negative 1, if I took the derivative of this, would end up being that with the 1/2 on the bottom, because this is the 1/2 right here. This is the 1/2. Okay, so that works out. On the other side, again, you could do it by any method you want. You can change this to be x to the negative 1/2, which is what I recommend. Over here, what I did was I just said 1/2 y minus 1 to the negative 2. That's how I did each side. And I was able to do that fairly easily. All right, on this side, we end up with 2x to the positive 1/2 plus c. Remember, you have to put a constant on one side. At this point, let's plug in our initial condition. So we end up with negative 1/2, and in our initial condition, x is 1 and y is 2, so 2 minus 1 to the negative 1 power equals 2 times 1 to the 1/2 plus c. All right, at this point we can solve for c, and we get c is going to be negative 5/4. So let's plug that in and finish solving. So let's do that over here. We have negative 1/2 y minus 1 to the negative 1 equals 2x to the 1/2 minus 5/2. Y minus 1, let's go ahead and multiply everything by, we could go ahead and multiply it by negative 2. So that gives me negative 4x to the 1/2 plus 5. And then solving this, we are going to go ahead and solve for, we could put this as 1 over y minus 1 equals negative 4x to the 1/2 plus 5. We need to solve this for y. So just simply cross multiply at this point, and you'll get cross multiply, then add this 1 over. So you'll get 1 over negative 4, and I'm going to change this x to the 1/2 to be root x, plus 5, plus the 1. That's what your y equals. All right, let's take a look at the next one. The next one says, let f be a continuous function defined on a closed interval from negative 1 to 4. The graph of f is shown and consists of 3 line segments. Let g be the function defined by that. G of x is equal to 5 plus the integral from 2 to x of f of t dt for negative 1 to 4. Okay, so let's go ahead and see if we can move this whole thing up. Oh, it's going to give me a hard time, so we'll have to do it all in parts here. Okay, so in fact, let's just get this all up over here out of the way so we could do the whole question. All right, let's take a look at this. This one says we need to find g of 4. So g of 4, and we're given this integral. So that means g of 4 is equal to 5 plus the integral from 2 to 4 of f of t dt. Now here's our f graph, and f by this is this integral. So let's take a look. So we need to integrate f from 2 to 4. All right, so let's find the areas of all of these anyway. This is at negative 1, so the area inside of here is going to be 2. The area here, so I'm finding the areas of all these bounded regions, is going to be 2 by 1, so that'll be 1. And the area here is this triangle, and that's 1 by a height of 4, so that'll give me 2. All right, so now if we wanted to find from 2 to 4, that's going to be negative 1/2. We should put this as negative 1 so we can understand that that's below the axis. It's going to be negative 1 plus the 2. So that means this is going to be 5 plus, so this region right in here, let's point it out again. This is from here, that's a negative 1/2, because the whole thing is negative 1. So we just need negative 1/2, and then the region above here is 2. So that's negative 1/2 plus 2. And that ends up equaling 5 plus 1.5, which will give me 6.5. Okay, the next one. On what intervals is g increasing? Well, we need to know when g prime is greater than 0. So g prime, we know, is our f of t, so we want this to be greater than 0. And where is it greater than 0? Well, it's above the axes from -1 to 1, and then from 3 to 4. So that's the intervals where this graph of f is greater than 0. So this happens from -1 to 1, union 3 to 4. Or you could write it doesn't matter, you could write it -1 less than x less than 1 and 3 less than x less than 4. Either way that you write that. Okay, next one. On the closed interval, find the absolute. Absolutes, we need to make sure we test endpoints. So what this is saying is we are looking for g prime of x to be greater than 0, right? We have to find our critical points. And this is when f of x is equal to 0, and this happens at 1 and 3. Okay, so our critical points over here are at 1 and at 3. So now let's continue on. So we need to test g of 1, g of 3, and then don't forget g of -1 and g of 4. Why are we testing these? Because these are the endpoints. So we have to test all that. So let's just go ahead and do that. Let's start with g of -1. We'll just start in order. This gives me 5 plus the integral from 2 to -1 of f of t dt. And I'm going to switch this around to be 5 minus the integral from -1 to 2. So I flip the bounds. And this ends up being 5 minus, and from -1 to 2, that gives me 2 plus, or 2 minus a half, because that's below the axes. And that ends up being 3.5. We're going to do the same thing now for g of 1. This will yield 5 plus the integral from 2 to 1 minus, so this ends up becoming, I'm going to flip this, 5 plus the integral from 1 to 2, and, oops, I should put a negative there since I subtracted that. Let's see if at least maybe the eraser tool will work. Yes, it's working. And so this will be minus. And then this ends up being 5 minus -1/2, which gives me 5.5. Okay, let's go ahead and now do g of 3. And that's going to be 5 plus the integral from 2 to 3. So this becomes 5 plus, now that region is going to be -1/2, and so we will get a total of 4.5. Okay, so now we need g of 4, because these were the endpoints here. And let's go ahead and test this one. We get 5 plus the integral of, this will be from 2 to 4, and this becomes 5 plus, now from 2 to 4, we end up with -1/2 plus the 2, and that'll give me 6.5. So here we go. Let's take a look and analyze all this. This we can clearly see is the absolute maximum at, this is the absolute maximum value. Oops, can't write right now. Let's say value at x equals 4. And this one is the absolute minimum value at x equals 3.5. Oops, 3.5. So we've got an absolute maximum value at x equals 4, and the value is 6.5. We have an absolute minimum value at x equals, this should be -1. I don't know why I wrote 3.5. Let's fix that. And that should be at -1. Okay. All right, let's do that last one here. What this is asking for, take a look. Let h of x be that. And we need to find h prime of 2. Well, we need h prime of x. Well, that means we're going to use the product rule. This question is asking, do you know how to use the product rule? And for this one, we're going to say first times the derivative of the second plus the second times the derivative of the first, which is 1. Let's plug in the h prime of 2, and this will end up being 2 times g prime of 2 plus g of 2 times 1. And here we end up with 2 times g prime of 2. We've already done g prime of 2, I believe, and that comes out to be negative 1. If you actually just look at it, we haven't done it. So here we go. G prime of 2, we're just going to look at the graph right here. And we get a negative 1 value because G prime is the F graph. So this is going to be now plus G of 2. G of 2, remember G of 2 is going to be the integral from 2 to 2, and that's just 0. So that's going to be plus the 5, because that was our initial condition from up here. Don't forget about that. So this will just be 5, and this ends up being a value of 3. There we go. All right, let's move on to the next problem. Okay, so let's go ahead and enlarge this a little bit. And on this one, it says Katie rode a stationary bike. The number of rotations per minute of the wheel of the stationary bike at time t minutes during Katie's ride is modeled by the differentiable function r, or 0 to t to 9 minutes. Values of r of t for the selected values are shown in the table. Okay, so take a look. We need to estimate r prime of 4 for part A and show our computations. Well, we don't have a 4 right here, but we can use what's next to it to estimate this. And since we can't take a derivative there, we'll have to find it by estimating the average. So we have to take the closest values. And since this is an instantaneous, we can't get an instantaneous out of this. We need to average it out. So in this case, we're going to say this is r of 5 minus r of 3 over 5 minus 3. And that yields 112 minus 95 all over 5 minus 3, which is 2. And put this in our calculators, and this is 8.5. Or you can just work it out, because this is still non-calculator here. Okay, for part B, it says, is there a time at which r of t is from 3 to 5, 106 rotations? Well, let's take a look. R of 3 is 95. R of 5 is 112. If I'm going from this point at 3 to here at 5, and however I connect it, this is a lower value, this is a higher value. And we know that it's continuous because it was given in the problem. It's a differentiable function, so that means it's continuous. So here's 106. Will I cross 106? Yes, absolutely. I don't know where, but somewhere I will cross 106, and that's by IVT. So by IVT, there must be a value C, or there must be a C. Let's write this correct. Must be a C such that R of C equals 106. And it's because it's differentiable, and since it's differentiable, it's continuous. So our answer is yes. Okay, use left Riemann sums with 4 subintervals. Let me set it up, and then I'll move this up a little bit. So I'm going to quickly sketch over here a graph of what's happening. At 0, we have 72. At 3, we've got 95, so it's a little bit higher. So this, I need a left Riemann sum, so I'm going to start on the left side, go like this. 3, we got 95. So this will go to 5 right here, which is 112. So that will go like this. Then the next one starts at 112 and goes to 6. And 6 has a height of 77, so it came right back down. So 6 has a height of 77, so we're down here. And then all the way to 9, which has a height of 50. That's even lower, so but we're still going to be at that height like that. So that's just a rough sketch of what's going on because I used left Riemann endpoints. All right, so we've got, so that means we need the sum of all these rectangles. And for the first rectangle, it will be 3 times 72. That's a height of 72. The second one will be 2 times 95. The third one will be 1 times 112. And the last one will be 3, a width of 3, and has a height of 77. And I'm going to spare you the formalities. Here, we'll write it out. This is 216 plus 190 plus 112 plus 231. And all this comes out to be 749. And what does this mean? This means this is which is the total number of rotations from t equals 0 to t equals 9. And that's our answer. Okay, let's move this up. Oh, good, it's all moving up together. Bryce also rode a stationary bike. The number of rotations per minute of the wheel during his ride is modeled by that. Find the average number of rotations from 0 to 9. Okay, so what we're looking for here, we know that S of t is the rate that they've given us by. So they've told us that this is our rate. Since we need the average, this is an average value. Find the average number of rotations per minute. Notice the units. We're finding the average number of rotations per minute. So this is an average value because we have a rate and we want to end up with a rate. So this ends up being 1 over 9 minus 0 from the integral from 0 to 9. And this is of S of t dt. And let's go ahead and, oops, I already did that. Let's go ahead and integrate this. And when you integrate this, you'll end up with 40t. And then the other part is going to end up being, okay, so I have sine, so that's, our constant is 2 pi. I have sine, so we're going to end up with cosine, and kind of messing around with this a little bit. You could do it through guess and check. You could do it through substitution. I ended up with 360 cosine pi over 2. Oh, sorry, cosine pi t over 18 on the bounds from 0 to 9. Okay, so this, you could do it through guess and check or substitution. I did it through a guess and check method. I just kind of quickly in my head said 20 pi, that's a constant. I'm not going to worry about that. And this ends up being, this is the sine of pi t over 18. So 20 pi I'll put on the outside. Here I end up with cosine, but it's got to be a negative. So we'll throw a negative out there. And I said pi t over 18. But then when I chain rule it to try to get that, I'm going to have to multiply it by 18 over pi to get rid of these that I have. Okay. So this is the correct answer. Again, it doesn't matter the method you choose to get to that. All right, let's complete this. Plugging in 9, I'll get 360 minus 360 cosine pi over 2 minus, when I plug in 0, I'll get 0 minus 360 cosine 0. That goes to 1, and this ends up being 720 over 9, which is 80 rotations per minute. Okay. All right, next. These are calculator required questions, so let's take a look at these. And on this first one, it says, if f of x is equal to the integral from 0 to x of t minus 2 sine pi t over 2, which of the following must be true? For this one, it says f of x is less than 0 on the interval from 0 to 2. And that is, you can go ahead and graph this. So here's what I suggest is graph this on your calculator. Okay, so when we graph this, we end up with, we're just graphing this part right here, and really quick to show you on the side here, it ends up from 0 to 2 looking something like this. It's right below the axis, and here's at 2. And so the area ends up being negative, so f is f of x, which is the integral. Yes, it is negative. That works out. The next one is f prime of x less than 0. Look at all the slopes. It's all below the axes. All the slopes are, since this is f prime, remember f prime, if this is f and then I have the integral, that's going to undo itself. So I'm looking at the actual graph, and the whole thing is below the axis. So f prime is just the equation. So in this case, it's just the equation. And yes, it's below the axes. And then is f double prime. Well, f double prime in this case is the slopes. And these slopes are negative here, but then they turn to be positive. So this is a no. So the only thing that works is 1 and 2. All right, the distance between, the minimum distance between the graph of that and the point 3, 4 is, well, let's go ahead and graph this real quick and take a look at what's happening here. And again, my software is being a little finicky. Okay, so let's go ahead and take a look at this, and it looks something like this when we graph it. This is a parabola, and it will go through 0, 0 here. And the point 3, 4, 1, 2, 3, 1, 2, 3, 4, somewhere like, say, right here. And we need to find that distance right there. Well, we have to use a distance formula. Remember, we have x comma y, and that's x comma x squared plus x. So let's use the distance formula on that to the point 3, 4. And so the distance is going to be the square root of 3 minus x squared plus 4 minus x squared plus x squared. I should say, yeah, 4 minus. I shouldn't have put that parentheses there. Let's see if it'll let me knock this parentheses out over here. Okay. And this will be like this, squared. And okay, so we have our distance, and we can graph this. So what I suggest is graph this equation. And find the minimum value. So that's the equation we wrote, because trying to take the derivative of that and setting it equal to 0, it's just going to be a waste of time since this is a calculator required portion. So we just graph this equation, find the minimum value, and it ends up being right there. 1.399. So again, we're going to put this in our calculators, graph it, and find the minimum value. So I will let you go ahead and do that and compare it to that. And remember, when you find the minimum, all you have to do is second calculate minimum left bound, right bound, and just look for it on the graph. Moving on, let's go ahead and enlarge this and take a look at what we got. It says, let the area, or let R be the region bound by the graphs there. The base is a solid whose cross sections perpendicular to the x-axis are triangles. The height of each triangle is 1/2 the length of the base. What is the volume of the solid? So since we've got cross sections here coming out at you like that, that's basically what it's telling us. Let's go ahead and graph these and determine a couple points. So there's the graph, but we're going to put it in our calculators and determine a couple points. Well, this point of intersection right here is 0.5, 2, 3, 5, 9, 9. This point of intersection is 2.61799. So you're going to have to put these two equations into your calculator. Remember, we are always in radians, and find the point of intersection. We know that the volume is the integral of the area, and in this case we want to integrate, we have the area of a triangle, and the area of a triangle is 1/2 times the base times the height, and this triangle that comes out of the paper that looks like this is the base, and the base is going to be our top equation minus the bottom equation. So in this case, the area will say, and our height is going to be 1/2 that base. So we can end up saying this is 1/2. And now the length of the base, remember, it's this top equation minus the bottom, which ends up being sine x minus 1 minus sine x times this is going to be another 1/2 sine x minus 1, I'm sorry, this should be like this, 1 minus sine x. Okay, cleaning all this up, we get this area as being 1/4. Now combine all the like terms, do all the math in between there, and you end up with 2 sine x minus 1 squared. So the 1/4 here, it's just 1/2 times this 1/2, because it's half a base. So we have the 1/2 out in front, half a base, and we have the height. Okay, so this ends up being, that is correct. I'm just double checking my work. Sine x, and they're the same. The other ones go away, and then we end up with a 2. So 2 sine x minus 1. And this is squared, because I put it all into 1. All right, so the volume is going to end up being from these bounds, 0.5, 2, 3, 5, 9, 9 to 2.61799 of this 1/4 2 sine x minus 1 squared dx. Calculator, put it in your calculator. It's a calculator portion, just put it in your calculator. You don't need to try to do it by hand. This comes out to be 0.271758. So right here is B is our answer again. A lot of B answers on this one. Okay, finally, let's take a look at this last problem, and it says, let R be the region bounded by the first quadrant by the graphs of G and S. Be the region in the first quadrant. Let R be the region in the first quadrant bounded by the graph of G of S. Let S be the region in this first quadrant bounded between the graphs of F and G. The region in the first quadrant is bounded by the graph of F, and the x-axis has an area of 12.142. So they're telling us that that's 12.142 as far as the area is concerned. Okay. And the function G is given by that. So they gave us the G function, which is this one, and we know what this one is. F is not given. The graphs of F and G intersect at the point 4, 0. So we do know that this is 4, 0, and we don't know what these two values are right there, which we may not need. Okay, find the area of S. Well, the area of S is going to be the integral from 0 to 4, and this will be just the top curve minus the bottom curve. So this is f of x minus g of x dx, and this comes out to be the integral from 0 to 4. And I'm going to break this apart and say this is f of x dx minus the integral from 0 to 4 of g of x dx. They told us what this one is. This is 12.142. This one, we're going to do it on your calculators. So put it into your calculators, find out that one, subtract them, you get a total of 5.2039 square units. All right, moving this up. Let's take a look at the next one. A solid is generated when S is revolved about the horizontal line y equals 5, right? But do not evaluate the integral. Okay, so we have this situation going on right here. This one and this one intersect, and we have y equals 5, which is like right here. Okay, well, what we're looking to do, and that's just slightly above, you could see slightly above that, which is fine. We want the volume, and this is our f of x, and this is our g of x. And in this case, the volume is the integral of the area, and we are going to say that this is going to be pi, and we're going to go from 0 to 4. Again, we're moving this up this way, so what ends up happening is this is our little r, that is our big R. So we have our big R, so we want the line, since it's larger, minus the radius in this case, because 5 is up above it, it's a larger value. So we will say that this is going to be 5 minus g of x squared, that's our big R squared, and then our little r is going to be 5 minus f of x. And we'll go ahead and square that out, and that's our little r squared dx. Should kind of go like this. Okay, and that's it. That is our volume over here, because we've got the big R and little r. Remember, the volume is pi times the integral from r squared minus little r squared. Okay, and finally, our last problem here. R is the base of a sculpture. At all points, the distance x from the y-axis, the height of the sculpture is given by h of x at. Find the volume of the art. Okay, let's see if we can set this up and put this together here. All right, the volume, like we always say, is the integral of the area. This is the base of an art sculpture. So the area is going to be base times height. And in this case, this is kind of, r is a distance x from the y-axis. This is kind of a little confusing. What it means, this means that this is x to get g of x. That's what that means. So don't let that confuse you a whole lot. So the area is the base times height, which in this case, that's going to be our g of x. And this is 4 minus x. So this is g of x times h of x is the way we have to think about this. So the volume is going to be the integral from 0 to 4 of g of x, and then h of x is 4 minus x dx. So we'll go ahead and put this on our calculators again, since we know what this g of x equation is, and this gives us a value of 17.2433 cubic units. All right, hopefully this review has helped. Good luck studying, and make sure to hit that subscribe button.